Hi, in this video we are going to see about a Python IEEE project which is entitled as Automated Knee Osteoarthritis Prediction and Classification from X-ray Images Using Deep Learning, which is an enhancement of IEEE base paper title an Enhanced Knee Osteoarthritis Grade Assessment Framework Using Modified Compact Convolutional Transformer Model, which is an IEEE 2024 journal paper. So before seeing the execution of the project, let me brief about this project. Basically, this knee osteoarthritis is a disorder that affects the human body. It affects both men and women. In our human body, there is a component called cartilage. So this cartilage is a protective tissue which covers the bone ends. So this cartilage allows the smooth joint movement in a healthy state. It also prevents bone on bone friction. So in case if this cartilage is damaged, then there will be a severe pain and tear and also causing the knee osteoarthritis. So this knee osteoarthritis involves the breakdown of the outer cartilage layer, resulting in a painful bone friction. Basically, this knee osteoarthritis has two forms, primary and secondary. So primary knee osteoarthritis commonly affect the older individuals because of genetics or aging, that kind of thing. This primary knee osteoarthritis get affected. On the other hand, secondary osteoarthritis is linked to factors such as injuries, diabetes, or vigorous sports activities, rheumatoid arthritis. These kinds of things will be coming under this. So when compared to the 20th century, nowadays knee osteoarthritis is common and disabling the joint disease that has become twice than the 20th century. So there are more number of cases increasing day by day. So in this base paper, the authors have used the deep learning model for identifying the knee osteoarthritis. So in this base paper, the authors have proposed an approach involved developing a modified compact convolutional transformer model known as KOA-CCT-net as the foundation model. Basically, the authors have implemented the knee osteoarthritis detection using the deep learning, and also they have made the grade assessment, and they have achieved a test accuracy of 94.58% based on the knee osteoarthritis X-ray images. So here you can see the grades of the knee osteoarthritis. So here you can see grade 1, there are 5 grades. Grade 0 is normal, grade 1 is doubtful, grade 2 is mild, grade 3 is moderate, grade 4 is severe. And you can see the detailed components of this, and this is about the base paper. So kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system model. So in this proposed system, we are going to implement two different models. The first one is VGG16 model architecture. The second model is MobileNet V2 model architecture. The first model, VGG16 model architecture, achieved a train score of 93% and accuracy test score of 92%, whereas MobileNet V2 model architecture, we have achieved accuracy train score of 96% and accuracy test score of 96%. So basically, from the base paper, we have improved the accuracy score. So base paper has achieved 94.58%, whereas we have achieved 96%. So we have made the improvement from the base paper by applying MobileNet V2 model architecture. And coming to the data set part, let me show you about the data set part. So here you can see the classes, that is 5 classes: normal, doubtful, mild, moderate and severe. So here you can see the images that we are going to use for the normal cases. Just I'll show you few sample images by opening the images. So these are the X-ray images. So this is for the normal case, and second, that is a doubtful case. Third is mild case. So these images are from the mild case, and then comes the moderate case. So these are the images that we are going to use for the moderate case, and finally the severe case. So these are the images that we are going to use for the severe case. So these are about the data set part. Now let us go into the project abstract. So here you can see the proposed title, and here you can see the IEEE base paper title, and this is about the IEEE base paper abstract. So coming to our proposed project abstract, as mentioned, we are going to predict the knee osteoarthritis, which is a prevalent degenerative joint disease that significantly impacts the quality of the life. So early and accurate diagnosis will help the patients and make the treatment better. So this project title, Automated Knee Osteoarthritis Prediction Classification from X-ray Images Using Deep Learning, presents a novel approach for diagnosing and grading the knee osteoarthritis using deep learning model. So this project, we have used Python for the backend and Flask as a web framework, and HTML, CSS, JavaScript for the front end part. So two deep learning model, VG16 and MobileNet V2 has been deployed for the model, and there are 5 categories which I said you, that is normal, doubtful, mild, moderate and severe. So this grading system is being based on the Kellgren and Lawrence grading system. So those are the person who have made this data set and presented this data set model, and the data set contains 1650 high quality 8-bit grayscale X-ray images. Those are collected from the reputable hospitals and diagnosis center using ProTech PRS 500E X-ray machine. So from this machine only the data set has been collected, and this is referred from the Kaggle source, and each images has been manually annotated by 2 medical experts for accuracy and the reliability. So in the VG16 model architecture, we have achieved train accuracy of 93% and test accuracy of 92%, and MobileNet we have achieved train score of 96% and test accuracy of 96%. So we have used performance metrics like accuracy, precision, recall, left measure and confusion matrix to compute each model comprehensively. So those details have been summarized in the abstract part. And coming to the existing system part, so we are going to consider the base paper as the existing system. So in the existing system part, we'll be describing about the base paper, where they have used modified compact convolutional transformer model as a foundation model, and they have achieved a test score of 94.58%, and they have used 110,232 raw X-ray images, and they have used data augmentation employed using the deep convolutional generative addressing network to synthesize the additional training sample to ensure diverse and balanced data set. And they have used some advanced pre-processing techniques also applied, which include like AHE, that is adaptive histogram equalization, to enhance contrast, fast non-local means to reduce noise, and image resizing. Those things have been described in the existing system part. And coming to the disadvantages of the existing system, so the main disadvantage is complexity of the model architecture and dependence on large data set and time consuming data pre-processing and synthetic data limitation, scalability concerns and higher resource requirements. So these are the few disadvantages of the existing system that has been listed in the disadvantages of the existing system part. And coming to the proposed system, so as mentioned earlier, we are going to focus on automating the prediction classification of the knee osteoarthritis using deep learning, and the framework, that is the development framework, contains the back-end web framework, and the front-end part contains the data set details. Here the data set we are going to use 1650 X-ray images for the training purpose, and the image characters annotation details have been described in it. And coming to the models, we are going to use VGG16 model and the MobileNet V2 model. Then their performance evaluation matrix and visualization analysis part will be done. So those it will be described in the proposed system part. And coming to the advantages of proposed system, so enhanced prediction accuracy is the main advantage of the proposed system, and efficient data utilization, comprehensive evaluation metrics, user-friendly web interface, scalability and flexibility, improved workflow efficiency, visualized results, cost-effective solution, real-world applicability. So these are the few advantages of proposed system that has been described. And coming to the system architecture, so we are going to give the input as the knee X-ray image data set and pre-processing feature selection made, and VG16 model architecture and mobile net V2 model architectures are applied, and predicted result will be like normal, doubtful or mild, moderate or severe case. And finally we'll be showing the performance analysis in the graph part. So this is the system requirements. So these are the minimum hardware requirements and the software requirements. The best project can be executed in Windows 10 or 11, and coding language we have used is Python 3.12.0. Web framework is Flask. Front-end part contain HTML, CSS and JavaScript. And this is the reference of the IEEE base paper that we have taken. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of Python library installed in your system. So now let me go into the source code location. Inside that we have this knee osteoarthritis using deep learning folder. Inside that we have the app.py file. So here in the address bar, let me type cmd and click enter. So the command prompt window open in the exact location of it. Now type Python space app.py and click enter, and kindly wait for a few minutes. So now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it and click enter. So now you can see the project home screen or welcome screen with the project title, automated knee osteoarthritis prediction and classification from X-ray images using deep learning. So first click the login menu. So now it will be navigated to the login page. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part where you need to upload an image. Before uploading, you can see an option called here model. So here we have had a drop down containing both VG16 model and mobile at V2 model. So you can select whichever model you wanted, and the result will be according to the model you have selected. So now let me select the choose file option. Now go into the project source code location. Here we have the given you the few test samples. You can select whichever you wanted. So now let me select a case from this and select an image, and now you can select from the drop down whichever model you wanted. Let me select the VG16 model and then click the submit button. So now you can see the prediction result in the prediction result page. So in the prediction result page, you can see the image that we have selected, and also you can see the model that we have selected as VG16, and the prediction result is doubtful. And if you wanted to check with other case, let me go to the preview menu again, click the preview menu again. So now I'll select the same image and I'll just change the model to mobile VNet V2 and then click submit. So now let us see the predicted result of it. So now you can see the image that you have selected and the model that you have selected is mobile net V2, and prediction result is also same, that is predicted correctly as doubtful. So now let me go to the preview part. Now let me go to the choose file option, and now let me select another case. Let me let the model be VG16 itself and click submit. And now you can see the image that is selected and the model selected is VG16 and the picture result is mild. Now let me go to the preview part again, select the choose file option, and now let me go to the case, select an image and click submit. So now you can see the predicted result is moderate. Now let me go to the preview menu again. Now let me go to this case and then click submit. So now you can see the predicted result is normal case. Now let me go to the preview menu again. Now let me select this final case and then click submit. So now you can see the printed result is severe. So now let me go to the preview menu. So now there may be few doubts, like some people will be thinking that we are having the names given in the folder as mild like this, so maybe like because of that it has been predicted. So let me show you, in case if you're, I'm just copying this mild and put it in the desktop. I'll just save it as XX. So now let me select the image from the desktop. Now I have selected this xx.png and let me click submit. So now you can see the printed result is mild. So it is not based on the name, so it is based on the training data that we have given. Accordingly it is predicting, because these are the few questions that I have already received from students. So that's what I'm saying you. And another thing, what happens if I'm going to give some other image, if it is not a data set image that we have trained. For example, you are not going to give an X-ray image, instead you are going to give some fruit image or animal image like that. So what will be the result? So the result will be like, it will be showing any of these 4 cases only, 5 cases only: normal, doubtful, moderate, because the model is being trained with these 5 classes only. So the model does not know about any other classes. So whatever the images that you give, it will be predicting, it will be showing these classes only. So if you wanted to give some other images, you wanted to give only the images that is available in the data set. For example, if you wanted to give some other images, you can give only the similar images of the X-ray knee osteoarthritis X-ray images. Other than that images also you can, but it should be in the same dimensions and according to the same data set feature. So in case if you are giving that, it will be predicting accordingly. If you are giving some other images that is not related to the project, it will not predict, it will show some random result only. So this was also the other doubt that you will be having, so that I have cleared it. So now let me show you finally a case that I'll just show from the data set part, that is from the train part. I'll just select some other image. There are lots and lots of image. Let me select an image and then click submit. So now you can see the printed result is moderate. So in this way you can just select the images that is available in the both the training and test part, and with all the 5 cases, and also you can select the model, 2 different models, and you can show the different kinds of results and save it. And now let me move to the performance analysis part. So just click the performance analysis part, it will be navigated to the performance analysis part. So in the performance analysis part, we'll be having the performance analysis parameter, accuracy, precision, recall and F measure for both the models of VGG16 and the MobileNet V2. So the first part for the performance analysis part contains performance analysis of the VGG16 model. So here the accuracy score is 0.93, precision value is 0.91, recall with 0.93, F measure with 0.93. And here you can see the confusion matrix for the VGG16 model, which contains the true and predicted label for all the 5 cases of normal, doubtful, mild, moderate and severe. And then comes the performance analysis for the MobileNet V2, which contains accuracy of 0.96, precision with 0.94, recall with 0.96, F measure with 0.96. And then comes the confusion matrix for the MobileNet V2 model, which contains the true and predicted label with all the 5 cases of normal, doubtful, mild, moderate and severe. And finally let us go to the chart part. So in the chart part, we'll be seeing the static visualization chart. The first chart contains the model accuracy chart. So the model accuracy chart will be showing the model accuracy score for the VG16 and the MobileNet V2. So VG16 contains train score of 93% and test accuracy of 92%, whereas MobileNet contains a train accuracy of 96 and test accuracy of 96. And then comes the class distribution chart. So in the class distribution chart, will be showing the class distribution of the 5 classes whichever we have taken from the data set class distribution. So in the data set part contains normal with 22.2%, doubt with 16.7%, mild with 19.4%, moderate with 25% and severe with 16.7%. So those details have been depicted in this chart part. So now let me log out from this part. So before completing, let me show you the few frequently asked questions and answers for this project. So the first question is, what is the main objective of your project? So the main objective of our project is to automate the prediction and classification of the knee osteoarthritis using the X-ray images, which is based on the Kellgren and the Lawrence grades. And why did you choose this problem statement? So because knee osteoarthritis is a prevalent condition affecting millions of the people globally, but early detection and accurate grading often a limited resources constraint. So our project aims to bridge this gap by leveraging deep learning for automated, reliable and the efficient diagnosis. So what are the key deliverables of your project? So the key deliverables, like, it include web application where we can upload the X-ray images and get the prediction. The two deep learning models, VG16 mobile net, trained to classify the grades, and comprehensive performance metrics and analysis of the model. And what data set did you use and how it was prepared? So data set that we have used was contained 1650 X-ray images collected from the reputed hospitals and the diagnostic center. So these X-rays were labeled according to the Kellgren and Lawrence grading system, and it has been pre-processing is involved adaptive histogram equalization and automatic region of interest extraction based on the pixel density. Why did you choose VG16 MobileNet V2 model? So basically VG16 is a widely used CNN with strong feature extraction capability, making it suitable for the medical image analysis. And for MobileNet V2, it is a lightweight and optimized for performance and achieving high accuracy with reduced computational resources. That is the main advantage of the MobileNet V2. Then how do you pre-process and input X-ray images? So the pre-process steps include converting the X-ray images to an 8-bit grayscale format, applying adaptive histogram equalization for enhanced construct, automatic extraction the cartilage region of interest based on the pixel density, resizing images to input dimension required by deep learning model. What performance metrics did you use to evaluate your model? So for the performance evaluation metrics, we have used accuracy, precision, recall, F1 score and the confusion matrix. What are the key differences in the performance of VG16 and MobileNet V2? So basically VG16 achieved 93 train accuracy and test accuracy of 92%. MobileNet V2 achieved 96% of train accuracy and test accuracy of 96%, making it better performance model overall. How is the web application implemented? So we have used the Flask web framework as a backend framework, and HTML, CSS, JavaScript as the front end. So it allows user to upload the X-ray images, select a model, and view the prediction along with the performance analysis metrics. So how does the system ensure accurate predictions? So the models are trained on quality data and annotated data set, and pre-processing techniques like ROI extraction, histogram equalization improve the input quality. We evaluated the models extensively using performance metrics and ensured generalization through proper training testing splits. What are the classes that you are used to predict? So the classes are normal, doubtful, mild, moderate and severe. Can this system handle real-time prediction? Yes, this lightweight mobile V2 model ensures fast inference, making the system capable of real-time predictions in clinical settings. What is Kellgren and Lawrence grading system? So basically this is a standard Kellgren and Lawrence grading system is a standard widely accepted method for classifying the severity of the knee osteoarthritis based on the radiographic features such as joint space narrowing and bone deformities. How does this project benefit the medical field? So the answer is reduces the radiologist workload by automating the knee osteoarthritis diagnosis, provides consistent and objective predictions, enhances early detection and treatment planning. What challenges did you face during the project? So the challenges include that acquiring high quality annotated data set, pre-processing complex X-ray images, optimizing the model performance for both accuracy and speed. How does your system compare to the existing system? So compared to the existing system, we have achieved better accuracy, whereas existing system achieved 94.58 and we have achieved 96%. Can the system be expanded to other medical condition? Yes, the system can be in future we can adopt the various medical conditions, and according to the model can be developed with the appropriate data set and modifying the pre-processing pipeline. So these are the few frequently asked questions and answer which may be helpful to your Viva voice. And this is all about the project automated knee osteoarthritis prediction and classification from X-ray images using deep learning. And thank you for watching.